Hi everyone, this is Mrs. Trigno again, and this is page 2 of the Chapter 5 test review. This is review number 1, so this is the one that was handed out in class and everyone was supposed to complete. Okay, number 5 is a system of 3 equations. You have not seen one with 3 equations before, but that doesn't change how you solve it. The principle is still the same. I have z equals 3x and y equals 4x minus 5, so I see right here that z and y are already isolated. I would do this with substitution, and I would take this 3x and plug it in for z up here, and I would take this 4x minus 5 and plug it in for y here at the same time, and you'll see what's going to happen then. So if I plug both of those things in, this equation will now look like this. 3x plus 2 times 4x minus 5, okay, that's my y, plus z, which is equal to 3x, is equal to 18. Okay, so a long equation now, but it's all x's. So now we can just solve for x. So let's take this 2 and distribute. So now I have 3x plus 8x minus 10 plus another 3x is equal to 18. Combine my x's. Looks like I have 3, 8, and 3, which makes 14x minus 10 equals 18. Add the 10 on each side. 14x equals 28. Divide by that 14, and x will equal 2. Okay, now for this one we also need to go back to find not only y, but z. We need to find y and z. And knowing that x equals 2 allows me to plug in to find what z equals and what y equals. So if z equals 3x, that means z really equals 3 times 2, which is 6. And if y equals 4x minus 5, then y equals 4 times 2 minus 5. That's 8 minus 5, which is 3. Now for these ones, you can't really write your answer as a coordinate. If you were going to, I would write it as x, comma, y, comma, z. You would have to go in that order. But it'd probably be easier for you up here just to write x equals 2, y equals 3, and z equals 6. And that's what I'm looking for you to do here. Okay, number 6 is asking me to solve this inequality. This is just like equation solving. In this particular inequality, there's something that's really tricky in terms of solving. It's a mistake that I see even when we solve equations. This says 6 minus all of this stuff in parentheses. We do need to distribute, but you want to make sure that you're not distributing everything. You're only distributing what's exactly right in front of the parentheses. So this negative sign is going to get distributed. The 6 gets left alone. So I have a 6, I have a negative 4, and I have a negative 2x. So notice none of that stuff is getting multiplied together. What I really did was multiply everything through by a negative 1. Okay, but the 6 did not play into that at all. And that's a mistake that I see a lot. It's greater than 10. Well, 6 minus 4 is 2, so now I have 2 minus 2x is greater than 10. I would first move this 2 over to the other side because this 2 doesn't have an x on it. And notice that that is a positive 2. So to move it, I'm going to subtract 2. And when this comes down, this is a negative 2x is greater than 10 minus 2 is 8. Now, I'm going to rewrite that up here because this next step is really important. My next step would be to divide by negative 2, except remember that this is an inequality, and I just divided by a negative number. So when I do that, my inequality has to flip directions and point the other way, and I'm going to get x is less than negative 4. So that's my solution. There's no equal bar here, so I'm going to use an open circle on negative 4, and less than would be to the left, so I'm going to shade this way. Okay, And that's what I'm looking for number 6. Okay, number 7, this is a linear inequality. So notice the difference between this one and the one above it. Here we were only dealing with one variable. Here we have a y and an x. Okay, so these are the ones we graph on the full coordinate plane. Now these are just like graphing linear equations. I'm going to start at the y-intercept, which is positive 3. Okay. And then my slope here is 2 over 1. So I'm going to go up 2 and over 1, up 2 and over 1. There's no equal bar, so this is a dotted line. And I had a lot of people asking if I wanted you to shade. Anytime it's an inequality, you are required to shade. Because what this is saying is I don't want to just see where y is equal to 2x plus 3, which is what the line shows me. I want to see everywhere where y is smaller than that. Remember, y gets smaller as you go down, so that means I'm shading underneath the line. The whole bottom half of this graph should be shaded. Sorry for my messy shading job. But everything underneath that line should be shaded. Hopefully you can see that okay. Okay, and then the last part of that question says identify 2 points that satisfy the inequality. Well, remember, we just shaded all of the points that would satisfy the inequality. So you pick anything you want that's in the shaded area. However, because this is a dotted line, the line itself does not count. So I can't pick these points that are on the line, but I can pick anything that's shaded. So I'm just going to kind of randomly pick out 2 points. I don't care which ones. Okay, I'm picking 2 points that are in the shaded area. And then let's see, the coordinates of this first one I picked, looks like it's over to the right 1 and then down 2. So 1, -2 would be one of them. And then this one, oh, why did I pick one so hard to count? 1, 2, 3, 4, 5, 6, 7, and then up 3. So I'm thinking that's 7, 3. But again, you could pick anything you wanted in here. There are an infinite number of possibilities for this question. So pick anything that's shaded. I just randomly picked 2 that I liked. Okay? All right, that's it for page 2.